Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 8 on additional geometric terminology. So we've seen a bunch of geometric terminology so far. We spent a long time talking about different pairs of angles and all the terminology associated with them. In our previous lesson we looked at angle bisectors and perpendicular lines. And in this lesson we just want to take a look at some final pieces of terminology. They're not going to be our last pieces of terminology, but for now they will be. So let's get into them. Now, midpoints. Now there's a great deal of terminology associated with the study of geometry. Much of it has descriptive names that help you understand the idea behind the term. And we begin with something very simple, the idea of a midpoint. Let's take a look at the idea of a midpoint of a line segment. The midpoint is the unique point on a line segment that divides, also known as partitions, the line segment into two segments that are the same length, also known as two congruent segments. All right, so this is very easy, right? This idea that, okay, we've got a line segment, right, and it's got a certain length. There is one and only one point on this line segment, somewhere, right in here, where if you put that point in there and then you look at the segment that goes from A to that point, and look at the segment that goes from B to that point, those two segments will be congruent. They'll be the same length. So let's take a look at exercise 1. Let's find the midpoint of this segment. Given segment AB shown, do the following. Letter A, find the length of AB in centimeters. All right, this is simple enough. Go ahead and take your ruler, measure that quickly. Hopefully it'll turn out to be a nice number, and then we'll move on from that. All right, well, let's do it. Real easy. We bring our ruler up. I tried to make this a nice length. Again, depending on photocopying, it may or may not be for you, but it looks like the length of AB is 8 centimeters. I'm going to leave the ruler where it is for right now. Let's take a look at letter B. Based on A, plot the midpoint of AB and label it as point M. Okay. Great. Well, obviously the idea of a midpoint is that we're going to be taking that distance, 8 centimeters, and we're going to divide it by 2 or multiply it by 1/2, and we're going to have two segments that are each 4 centimeters long. There's our 4 centimeter mark right there. So I'm going to move my ruler, and I'm going to put M right there. And again, the idea is now that I've got it should have been a 4 centimeter segment there, and a 4 centimeter segment there. Okay, and finally, letter C, make a formal statement about the congruence of two segments. All right, so what I'd like you to do is write down a statement that claims that two segments are congruent. All right, now remember, it doesn't matter how we write down the letters for a particular segment. So I'm going to say segment AM is congruent to segment MB. We could also say segment MA is congruent to segment MB, or segment AM is congruent to segment BM. It doesn't matter. All right. So simple idea. And the terminology itself is perfect, right? The midpoint. The point that's in the middle of a line segment. And of course, we can't talk about the midpoint of a line or array because those things extend forever, right? So there is no point that sort of divides them in half. We only talk about the midpoints of line segments. All right, let's take a look at exercise 2, which is also on midpoints. In the diagram below, all points shown are collinear. H is the midpoint of EI, F is the midpoint of EH, and G is the midpoint of FH. If FG equals 5 inches, what is the length of GI? All right, I love this problem. Should be easy. Start to fill in things on the diagram that you know and see if you can figure out the length of segment GI. All right, well, let's start to label. We know that FG is 5. We also know that point G is the midpoint of FH, which means this also must be 5. Now, we know that point F is the midpoint of EH, which means that EF and FH have to be the same. That's got to be 10, and that's got to be 10. All right, but we also know that H is the midpoint of EI, and so if all of this is 20, then this is also 20. All right, so I can kind of just sort of build my way up. Now, we have to be very careful though in giving the length of the segment they want, right? The actual segment that is asked for here, let me go in a different color, is GI, and that happens to be this segment, which includes this length of 5, this length of 20, and so the length that I'm looking for is 25 inches. All right, simple enough, right? And again, using ideas about midpoints that are pretty evident. Let's keep going. All right, now let's talk about a segment bisector. And a concept that is closely related to the midpoint is that of a segment bisector. And it's very similar to an angle bisector. Let's take a look. Segment bisector. Any line, segment, or ray that passes through the midpoint of a given segment is known as a segment bisector. All segments have only one midpoint, but an infinite number of segment bisectors. All right, so again, segment bisector is just like an angle bisector. The biggest difference is that for any given segment, there are an infinite number of segment bisectors because a segment bisector is simply a line or a ray or another segment that passes through the midpoint of a given segment. Wow, that was wordy. Let's take a look at exercise number 3. In quadrilateral ABCD shown, diagonal BD bisects diagonal AC. Which two line segments must be congruent based on the information given? Explain. All right, pause the video now and see if you can write down which two line segments must be congruent. You might as well write it down as a congruent statement. All right, and then see if you can explain why that's the case. All right, well, we are told that BD bisects angle AC. Hey, we're still in red. I think I'll go back to blue for right now. All right, now that means literally that BD is the knife and AC is the thing being cut in half. All right, so BD right here is sort of our knife, if you will, and AC is the thing being cut in half. And therefore, that means that AE is congruent to CE. AE is congruent to CE because BD, well, I can say passes through the midpoint of AC, right? That is the definition of a bisector. A segment bisector passes through the midpoint of a given segment. So when we see BD bisects diagonal AC, that means that BD must pass through the midpoint of AC, which means E must be the midpoint of AC. All right, great. Now, we can talk about combining the idea of a segment bisector, of course there's an infinite number of those, with a perpendicular line to introduce another important geometric concept, one that you're going to get sick of hearing about eventually, and that's of a perpendicular bisector. So let's talk a little bit about perpendicular bisectors. A line, ray, or segment that both bisects a line segment, so it passes through its midpoint, and is perpendicular to the line segment is called a perpendicular bisector. Every line segment has a unique line that is the segment's perpendicular bisector. So, right, any given line segment, there's an infinite number of lines that are perpendicular to it, right? And in a given line segment, there's an infinite number of lines that bisect it. But there is only one line that both bisects the line segment and is perpendicular to it at the same time, and we call that the perpendicular bisector. Let's take a look at exercise number 4. The same segment from exercise number 1 is shown below. Use a ruler again to find its midpoint. Then use a protractor to help draw the line that is the perpendicular bisector of AB. All right, well, see if you can draw the perpendicular bisector of AB. All right, well, first things first, we know that it goes through the midpoint of AB, so let me find the midpoint of AB. Bring this down here, rotate, still 8 centimeters. Right here is my 4 centimeter mark. I can get rid of that. So right there is my midpoint. I think I'm going to label it M. Okay, great. Now again, I could draw, tons of different lines that would then intersect AB at M. But there is only one line that will actually intersect AB that is perpendicular to it, right? So to find that, at least for now, I'm going to bring my compass up here, rotate it so that it lies along the edge of the compass, find that 90-degree angle, just maybe make a little mark like that. And now bring my straight edge up. Should be a little bit easier for you than for me. And let's draw our perpendicular bisector. There it is. The perpendicular bisector of AB. It is going to be an amazingly important idea, this perpendicular bisector. This idea that it's a line that cuts a segment in half, so AM has the same length as BM, and all of these things, right, are right angles. Okay, let's keep going. Let's work a little bit more with perpendicular bisectors. Exercise number 5. The figure shown below is known as a kite in geometry for obvious reasons. In kite MNPQ, it is known that PM is the perpendicular bisector of NQ. List the different pieces of information we can conclude from knowing that PM is the perpendicular bisector of NQ. All right, so write down everything you can tell me just from knowing that PM is the perpendicular bisector of NQ. Pause the video now and see what you can do. Well, perpendicular bisectors always kind of give us two pieces of information. One piece of information is the fact that this segment and this segment are congruent. I can do that by doing little dash lines like that. So I can say that NR is congruent to QR, right? And that's the whole bisecting part of perpendicular bisector. NR is congruent to QR. Great. But now the perpendicular piece is also important. And that's the fact that this, and this are all right angles. So angle NRP, angle PRQ, angle QRM, and angle MRN are all right angles. And that's it. Now, eventually we'll be able to conclude even more information based on the fact that that's the perpendicular bisector. But for right now, that's all we know. That's all we know. All right, final little problem. Exercise number 6. In the diagram shown below, it is known that segment AGB, line EGF, line CGD, AB equals 28, AG equals 14, measure of angle EGD is 26 degrees, and measure of angle BGF is 64 degrees. Is line CD the perpendicular bisector of segment AB? Justify your answer. All right, before we move on and we sort of like distill everything, I want to just take special mention of these 3 pieces of information that you're given. All right, and we've talked about this before, but I'm going to still bring it up a few more times because it's important. Sometimes you're given information in geometry and you're like, I don't know what that's telling me. Do you know what I mean? I mean, like at least these things. Oh, AB's got a length of 28, AG's got a length of 14, the measure of EGD is 26 degrees, etc. Those are solid. It's obvious what they're telling you, right? But why do they even say this, right? Well, we're given this information to let us know that A, G, B all fall in a straight line. Now I know they look like they fall in a straight line, but here we know for certain. And the same thing here, EGF fall in a straight line and CGD fall in a straight line. So those are all collinear pieces of information, right? Or pieces of information about collinearity. I'm not sure the information itself is collinear. Anyhow, so we've got these pieces of information that tell us that, and that's important because if these things aren't straight lines, if there's maybe a little bit of a bend, but we just can't see it because our eyes aren't good enough, like mine, well, then we make assumptions that don't work out so well. Okay, so anyway, is CD the perpendicular bisector of AB? Justify your answer. I'd like you to pause the video now and see if it is. All right, well, to figure out whether it's the perpendicular bisector, we have to do two things. First, we have to see if CD, right, bisects segment AB, and we have to see if line CD is perpendicular to segment AB. So I think the first thing I'm going to do is look at this length information. AB is 28, AG is 14, right? So AB is 28, all right, and AG is 14. That means that BG must be 28 minus 14, which is also 14. So this has got to be 14. Now that's good, right? That tells us without doubt that line CD bisects segment AB. All right, no question about it. G is definitely the midpoint. But now, is it perpendicular? Looks perpendicular, but is it perpendicular? All right, so first, we know that EGD, this angle right here, is equal to 26 degrees. And we know that BGF, this angle right here, that's equal to 64 degrees. I'll bring this 14 down here and this 14 down here so that it's not in our way. All right. Well, what does that tell us? You know, I mean, like I got an angle down here, I got an angle up here. I don't know. Well, one thing that we can do now is we can use vertical angles. And we can use vertical angles because we know these things are straight lines, right? So we know that thing is crossing that thing, it's crossing this thing. Right? So one thing I could do is I could say, well, if that is 26 degrees here, then the vertical angle to it up here is also 26 degrees. Now I can figure out that the measure of angle CGB is equal to 26 degrees plus 64 degrees, and that's 90 degrees. So this is a right angle, but as we've talked about before, when one of them's a right angle, they're all right angles, right? Because that angle has to be a right angle given that it's a linear pair with that one. This one down here has to be a right angle because it's a vertical angle with that right angle, etc., etc. So the answer is yes, because it both bisects AB and is perpendicular to AB. All right, let's wrap it up. So today what we did is we looked at additional geometric terminology. Specifically, we looked at the midpoint, we looked at a segment bisector, and we looked at the very important idea of a perpendicular bisector. All of this terminology is going to get used time and time again in geometry problems. And when you're told something like line AB is the perpendicular bisector of segment CD, you have to immediately know the information that that tells you. You can't be like, well, I don't know what perpendicular means, or I don't know what bisecting means. You've got to know what that information tells you moving on. So it's really important to pay attention to what you're doing on the homework and to really commit to memory what these pieces of terminology mean. All right, for now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.